Hello everybody, I will start my today's another live coding session. So today I will solve this question. I actually took this video a few hours ago, but unfortunately the screen sharing was stopped after 7 minutes. So I decided to take this video again. Obviously, I won't pretend that I'm struggling. Yeah, actually, in my first video, because this is a hard question, I struggled a lot. And after 40 minutes, I could solve this question. Yeah, which is a very good video, but unfortunately it's lost. So in this video, I will go for real quick and I will introduce 3 approaches. Okay, so giving a string containing just the characters, opening parentheses and closing parentheses, return the length of the longest bodied well-formed parentheses substring. Sounds good? So, okay. Let me start with the clarification. Yep. So in this question, for interface, I'm given the string s, and I will return length, which is integer. Yep. So this length is length of the longest varied well-formed parentheses substring. Yep. Okay. Obviously, I have to firstly, clarify the definition of the well-formed parentheses substring. I will write it here. Yep, so I have to think of this. Also, I will check the constraint. So in this question, the given string length is 0 or larger. The given string can be an empty string. So that may be what I have to take care. So, and as I can say, maybe this is the edge case, or maybe not. But so I'm giving the empty string. Obviously, I should return 0. Yeah, because there isn't any character, so I can't, create any bodied well-formed parentheses substring. Good. Okay, that being said, so let me start with thinking of the definition of well-formed parentheses substring. So when I given the string like this, I can say this is valid. But for this one, I can say this isn't valid. Also for maybe this one, not valid. And even though there are same number of opening parentheses and closing parentheses, this is not valid. Yeah. So let's think what I can say. So from this, I can say substring, or I should say string, is well-formed parentheses if opening parentheses has the dedicated pair closing parentheses later, and closing parentheses has the dedicated pair opening parentheses before. What I mean by the dedicated word is, for example, this case. Yeah, I should say this case. The opening parenthesis has a closing parenthesis pair, yes, and closing parenthesis, this one has the opening parenthesis pair, yes, and closing one, the second one, actually has this opening one, but this opening one is already taken by the first closing one. So I can say this opening parenthesis can be the pair of the second closing. So that's what I mean by the word dedicated. Yep. Okay, so I've clarified the definition of the well-formed parenthesis substring. So that being said, let me start with the first approach. So the first approach is quite simple. When I have the string, something like this, I start from each, string. So each position. Then I keep going. And when I find that I fix the start index and traverse the end index. And when the substring from start to end is buried, I update the returned max length. I initiated from 0, and every time I find, for example, this case, this is buried, so I update max length with 4. Yeah. Okay. So that's my idea. So in this case, I start from here, and end index is when it is here. I can say this start end is buried. So I update max length with 2. And when I move it, I can't find any more buried parentheses substring. So I have to notice, I have to take care that even if I find the first buried parentheses string with the start index fixed, I have to keep moving the end index because it may find the second, longer buried parentheses. For example, in this case, if I start from here and index start from here, and here this is buried, so ranks 2, and then here again this is buried, ranks 4. I have to take care of that, and I use stack for this. So stack should include only the opening parenthesis, and when there is a closing parenthesis, I pop this out, pop one element out as a pair. And when I find that I have the closing parenthesis, but there isn't any element in the stack, it means that there's no pair for that closing parenthesis. So in that case, the string is buried, and also I start the traversal of the end index, because even if I move that, it never becomes buried. For example, this case. No matter what comes later, starting from here, it never becomes buried. So it never becomes buried. So I stop this iteration here. Yep, so that's the basic idea. Okay, so we can write for each start, move end, and update max length. If with end string is and the character is closing and length of stack is 0, I will break. That's the end, as I said. And if length of the stack is 0, I can say current start to end is valid, so I update. Actually, this is the case. Yep, so this is basically what I would do. Okay, I start the implementation. Oh, and for time complexity, this should be O of n squared because for each start index, I move the end index. So it should be n times n is n squared. For space complexity, I have a stack, and stack can have up to O of n elements, assuming that there n element is n characters in the given string. This is the case when all the characters are opening parentheses. In that case, I keep pushing the opening parentheses into the stack. So in this case, O of n space complexity. Yep. So here, oh, I initiate the stack first. Then here, I check what is that end character. And if it's the opening parenthesis, I just have to push it into the heap. Sorry, stack. If it's a closing parenthesis, and if there is an element in the stack, I find the pair, so I pop one element out from the stack. Yep. Otherwise, this is the case when it is the closing parenthesis and there isn't any pair. So I can say this is invalid, so I break. Yep. And every time in the end, I check if length of the stack is 0. And if it is true, I update the max length. And in the end, I return max length. Yep, this is it. Let me quickly check. So I start with the edge case here. If it is the empty string, because this is 0, length of s is 0, there's no for loop, so I return max length 0. Yep. I passed this test case. Okay, a few more test case. Maybe one more. For example, this case, it should be 2. I will test it. So max length is 0 first. And for start index here, stack is initiated. Yeah. Then for end index from here, firstly, this is the opening parenthesis. So I just append this to the stack. Yeah. Then I go to line 71. Length of stack is not 0. So I go back to line 63 and move the end index. Now there's the opening parenthesis again, so I just append it to the stack. Then I go to line 71, length of stack is not 0, so I come back to line 63. I move the endpoints index again, and I find the closing parenthesis. And now I go to line 66, length of the stack is more than 0, so I pop this out. Yep. And in line 71, because length of the stack is not 0, I kept going, and that's the end of the inner for loop. I come back to line 61, and I move the start index, and tag is initiated with empty list again. And yep, for here, n is now opening 1, so this should be pushed into the stack. And I go to line 71, length of stack is on 0, so I come back to line 63. I move the end index, and it's now opening in parentheses. And length of the stack is more than 0, so I go to line 67. I pop out the element from stack, and I go to line 71. Yes, length of stack is 0, so current length is now 2 minus 1 plus 1 is 2. So max length is updated with 2. Good. And finally, I move the start index again in the outer loop, and stack is empty again. And for end index here, closing one, what I find is this is the case for line 68 because it's the closing parenthesis and the length of the stack is currently 0. So I don't even push this closing parenthesis at all, and I don't check line 71, and I go out of the loop, inner loop, and of the outer loop, and that's the end of the outer loop. So in line 75, I return max length 2. Okay, completely as expected. I passed. Good, so I'm pretty confident in my code. I cover those lines, I submit. Oh, B, just echo. Okay. And probably time limit exceeded. Yeah. Actually, in this question, I'm expected to implement the linear time complexity solution. So I work on the second one. So in this approach, okay, so let me see. So this is the approach I came up in my first video after maybe 40 or 50 minutes. So yeah, this is actually quite simple, but there's a kind of aha moment for me. So basically, in this kind of parenthesis question, I pushed the opening parenthesis like string, like this string into the stack. But instead, I push the index of opening parenthesis. Yeah. And what is good about this approach is that, let's think of this case. Maybe this case. So in this case, first 3 I append. So if I push the parenthesis string, what happens is that I push the first one, then I push the second one, then I pop out the first one. This is popped out. Yeah. And what I can see from here is there is the opening parenthesis. And what I can say is character immediately after this opening parenthesis, if I start the substring from there, it becomes a parenthesis. valid parentheses. Yeah, because if I start later than this, or I should say one character after this, I start from here, and there isn't any element in the stack if I finish the iteration. So it becomes the valid parentheses substring. Okay, so this becomes more easy to understand, I think, when I put more element here. For example, this one. So let me push index here. I push index 0, 1, 2, 3, and then at index 4, this one, I pop out this 3. And that's the end. What happens is that index 0 and 2 are still in the tag. But if I start from index 3, it becomes a valid parenthesis. So this is what I can say. But I have to think of two edge cases. So what if stack is empty after the traversal? Also, I have to think, what if there is no element opt out in stack when I encounter this closing parenthesis? So let me think of these cases. The first case is like this. In this case, I start from index 0, 1, and I pop out this and this. In this case, I can say, basically I move the end index, and as a result, when I come here, I pop out this element, pop out element 0, index 0, which is this one, when I reach, end index reaches here. So this becomes empty. So the answer is, I can say the whole string is, valid. So yeah. So basically, I can start the valid parentheses from the beginning. That's what I can say. And the second case, if I start from here and I find the closing parentheses here, in this case, what should I do? I start from here, then here I pop out this. Now there isn't any element in the stack. Yeah. So I can say this whole string is valid. And when I move here, actually I cannot include this into the stack. Also, what this suggests is if I include the, what should I say? So if I include this end character from start, it becomes invalid. Because as I said in the first approach, whichever character I append after this one becomes invalid. And also I can say, if I start later than this, it doesn't help because so for this is valid. So opening parenthesis should come first, which means that if I shrink, it becomes invalid. Yeah. This means that I start from the beginning. Yeah. Where should I start from? Yep. I have to start from here. N plus 1. Because it has too many parentheses. As I said, if I start from later than this one, first character, for example, this, it always have more closing parentheses, which doesn't have a pair in the end. Or I should say, the problem here is I can't find the pair of this closing one. So if I start later than this or this, I never can't find the pair of this. So that's why I have to, give up finding more valid palindrome and start from here. So, and when I do that, I keep appending the element in the stack. But again, the 3, 4, and in the 5 pops at this, 6 pops at this. And when I reach here, it pops as all the element, which means that the bodied parenthesis substring is from the beginning. But the beginning here is not index 0, but here. So I have to keep track of the end of the previous segment. I can divide the substring in this way. Yep, this is the approach. Okay, so I can say move and index. And for each end index, so push index to back or pop out or end here and start new substring from n plus 1. Yeah. And obviously, if I pop this out, if ranks of stack is 0, current valid ranks, which ends with current end index, is end minus start plus 1. Or I can say end minus. So, sorry, no. As I said, there are two cases. If there is an element in the stack, in this case, and current ranks is, top element, top index in the stack, top element in the stack, the current ranks is end minus top in stack. Otherwise, because there isn't top element in the stack, I remove previous end, or should I say previous boundary end. Yep. So I initiate pre-boundary with -1 first. Okay. So let me start the implementation with this, but for time complexity, it should be open, assuming that there are any characters in the string s, because I move the end index, so there are n steps. For each, it takes only the constant time. For space complexity, I need only the stack. It should be open space complexity. If, for example, all the character in the given string s is opening parentheses. Okay, that being said, I start the implementation. So if this is opening one, yep, this one. And if this is closing, and if there is an element in the stack, I pop this out. So I mean, pop the top element, which is the opening parenthesis, so I can find the pair of the closing parenthesis. Otherwise, it's the end, so I update the previous end boundary. And that's it. Yep. And every time I finish this, I calculate the current length. The current length is length of the longest valid parenthesis substring, which ends with current end index. Yep. So this should be if there isn't any element in the stack, I can say current max length is end minus previous end boundary. Otherwise, current max length is end minus top element in the stack, which is the last opening parenthesis index, which doesn't have a pair. Okay. And I update the return max length with this. Okay. So let me skip the dry run. Let me run my code. Okay, accepted. No, I have to comment this out. Oh, accepted. And we'll submit. Great, accepted. Yeah, on the second thought, I'm thinking of doing the dry run because it makes the understanding more clear for you. I will just go with this. So in this case, previous end boundary is -1, and max length is 0, and stack is empty first. And in line 80, I move the end index. And firstly, when it is a closing parenthesis, because length of the stack is 0, I go to line 87, and previous end boundary is now index 0. Yep. And I move end index again. And now I have index 1, sorry, index 1, and this index 1, which is the opening parenthesis. So in line 82, I push this opening parenthesis index into the stack. And I go to line 89 because length of the stack is not 0. I go to line 92 and current max length. So the longest valid parenthesis, which ends with index 1, is 1 minus 1 is 0. Yes, this is actually expected. So max length is not updated. Let's just say there's 0. Yep. And then come back to line 81. I move the index again. And now it's a closing parenthesis. I go to line 84 because there is an element in the stack. So I pop that from the stack in line 85. Now in line 89, because length of the stack is 0, current max length is end, which is index 2, minus previous end boundary, which is now 0. So this is now 2. So max length is updated with 2. And this is returned. Okay. So expected 2 and I passed. Yep. So this worked as expected. Yep. Okay. So finally, I will implement the final solution, DP approach. By the way, as I said, pushing indexes into the stack instead of opening the opening parenthesis string is a new idea to me, and it looks really nice. So I'd like to keep it in my mental memory, mental note. So the final solution is DP. I'm actually not sure about this idea. So after taking the first video, I took a look at the editorial. I scanned it and noticed that there is a DP approach, which takes only the linear time. So I will try to think how I can do that. So I think so I think what I can do here is I keep track of the length of the max length of the varied substring, which ends with that each index. So this is, let's just say, so I will keep track of this in the DP table. So for example, this, it should be 0. For here, it should be 2. Max length is a valid parenthesis substring which ends with index 1 is this one. And here, this should be 0. At least I can say this is 0. And here, this is actually 4. So how can I notice that? So probably the idea is that when I find the varied parenthesis, as I said, this is varied. was as a whole string, but I split it into two. And for this one, this is ranks 2. For this one, this is ranks 2. So when I'm here and I find the current group of bodied substring, let's just say, I will try to find the pair of the current closing parentheses. For example, for this one, the closing pair is index 2. So I can say length 2. But here I can concatenate this with the previous one. After that, take a look at index 2 minus 1. Yep. Which is the longest valid palindrome, which ends with index 1. And I took a look at that because this ranks is 2 and it kept as 2. It's a deep table. It should be 2. So this 2 plus 2. So this becomes the longest parenthesis substring, which ends with current index here. Okay. So let me verbalize this solution more. So actually, if this is the opening parenthesis, it immediately is 0. So if and if it is the closing parenthesis finds a pair. And I can say, if not found, zero is the answer. And if found, let's say j, the ranks should be I minus j plus 1, which is the current ranks, and j minus 1. So I can, append the parenthesis substring, which ends with index j minus 1, like concatenate that. So the rank should be this. Okay. Good. I wrote the pseudocode thoroughly because it's so confusing. The only problem here is how can I find the pair? So the pair is something I pop out. Yeah, with from stack. So again, probably I will, in the stack, I push this. Yeah. Okay. I think I can say yes. So now let me, do the compressed analysis. So time complexity, it should be O of n. When I take a look at the for loop to fill in DB table, I have to traverse all the index, which will take O of n. And independent tree, I can think independent tree, all the element. No, I don't have to think it in independent tree. Every time I do pop or push up to one element for each from the stack or into stack. So it should be n times constant is O of n. For space complexity, so I need the DB table, O of n, and also stack up to O of n. In total, it should be O of n. Good. Nice, that's implementation. If this is the opening parenthesis, obviously I don't find a pair with this, or I should say, max length of the valid parenthesis substring, which ends up this index is 0. I just push it into index into the stack, and yeah, DPI is 0. Otherwise, character is closing parenthesis, and if there is an element in the stack, I pop it out. This is the pair open parenthesis index. Yeah. So with that, I can say current max length, or should say DPI, is equal to I minus pair opening index plus 1. Oh, plus 1 plus DP pair opening index minus 1. Yep. But one thing I have to take care is if this pair opening index is 0, it becomes -1, which is out of the range of the DB table. So I should say current group length. No. Where should I name it? So last length. Last group length and groups groups length. Yeah, I think this is good. This and If this is 0, it becomes 0. Otherwise, it should be this. Okay, so now DPI is equal to last group's ranks and prev group's ranks. Okay, good. Otherwise, because Take's ranks is 0, yeah, I can't find the pair. So DPI should be 0. And I have to start the new segment from next. So wait, current ranks of stack is 0. I don't have to do anything on the stack. I can just say I should start the new, segment from the next index. Yep, that's it. And I return marks of DB elements. Okay. Let me quickly dry run. So I will think of the case like this. Let me go quickly. DB table is initiated with empty. No. And stack is initiated with empty rest. And for each index I, when it is the opening parenthesis in line 70, I append 0 here. And DPI is 0. Over good. And I come back to line 66, index 1. It is the closing parenthesis. So, and there is an element in the stack. So I go to line 71. Pair opening index is stack.pop, which is 0. So last group ranks is 1 minus 0 plus 1 is 2. Previous group's ranks is, because pair opening index denotes 0, is 0. So DPI is 2 plus 0 is 2. Yeah, as expected. And I come back to line 66. Now index is now 2. Here, this is the opening parenthesis. So I just append index 2 to stack. And I go to line 69. DPI is 0. And I come back to line 66. Now index is 3. So it's a closing parenthesis, and there is an element in the stack. So I go to line 71. I pop out index 2, and last group ranks is now 3 minus 2 plus 1 is 2. Previous group ranks is, because pair opening index is now 2, so it should be here, DP, index 2 minus 1, which is the index 1, so I get 2. So now I get 2 plus 2 is 4. This should be the longest valid parenthesis substring ranks, which ends with index 3. Yep. So I finish the for loop and return max of DB table, which is 4. Yep. So this is as expected. The only line I couldn't cover is line 76. So probably I can test it with something like this. Because here, this third parenthesis, yeah. But here, stack is empty and it's a closing parenthesis. So I should be able to cover line 78. Okay, anyway, almost covered all the lines and pretty confident. So let me execute my code. I comment this out. Ah, yeah, I overlooked the edge case. Probably I should have dry run with the edge case. Good. Okay, accepted. Again, this is the O(n) time compressed solution with bottom-up DP. Okay, so let me quickly wrap up. So today I solved the question, longest valid parenthesis. Yeah, for this question, I'm given a string, and my task was to find the longest valid parenthesis substring and return that ranks. So I introduced three approaches. The first approach is O(n) squared time approach. The idea is for each start index, I take the start index, or I should say, I start substring from each index, and I traverse the end index. And every time substring start to end is valid, I update the max ranks to be returned. Yeah. And for the second approach, the key result, I put the index of the opening parenthesis into the stack. With that, I could find the longest parenthesis ranks, which should be the top element in the stack plus 1. So for each end index, there is the start index, which forms the longest valid parenthesis substring. Good. And for the third approach, it was a DP approach. It looks a bit similar to the second approach in terms of I push the index of the opening parenthesis into the stack. But basically, the idea is I keep track of the longest valid parenthesis ranks for each index. Yeah. And based on the previous result, I can calculate the current result. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.